Hey Algebra 1, and thanks for tuning in. Today we're going to be looking at lesson 8.3, which is graphing in standard form, or ax squared plus bx plus c. We're going to be talking about a few different things, so make sure you have 7 things written in your notes today once you're done, and let's go ahead and get started. The first thing main thing we're going to work with is a zero of a function. And the nice thing is that you've already seen this back in chapter 7 when we solved by factoring. Zero of a function is basically the same thing. It's whenever you're trying to find x, when your function is equal to 0 or y is equal to 0. And these are going to be helpful because it's going to allow you to find the x-intercepts. So that would be what you'd want to write down in your notes. And if you want to copy down this example below it, you can, because the next one you're going to try. It says, sketch the graph of y is equal to x squared minus 81. Just remember what we would do here, that's the difference of two squares. So what we would do is factor it and then solve both for x. So our factoring of x squared minus 81 is x plus 9 times x minus 9. That's set to 0. You can get x is equal to 9 and x is equal to positive 9. So your zeros are x is 9, negative 9 and 9. What that would look like on the graph, your zeros would be the x-intercepts. So here's where negative 9, 0 and positive 9, 0 would be. And then you would have your vertex here at the bottom because your vertex is h, comma, k. And we'll talk more about how we can find that using standard form. Let's go ahead though and pause where we're at so you can write down what zeros of a function are. If you want to write down the examples, well, you can. And then once you're done, click play to see how it's done. All right, so this one you're actually going to try. We're going to go ahead and we're going to factor first and then solve the function. That's all we're going to try to do first. It does say to find the vertex, and just remember that the vertex is equal to h comma k, and you should be able to see that once you factor out. So let's go ahead and pause the video here and see if you can at least find the zeros of the function. If you want to try to go ahead and find the vertex, you can as well. Alright, so for this one, we're going to set the function equal to 0. And the first thing I'm going to do is I'm going to factor out a greatest common factor. I'm going to factor out a negative 16. The reason why I'm going to factor out negative 16 is because I want my first number, a, to be positive. So I'm going to get 4x squared minus 1. Once I've got that, then I can go ahead and see that this is a binomial, a difference of two squares. So once again, that'll be 2x minus 1 and 2x plus 1. And then I would set both of those equal to 0. I can't set this negative 16 equal to 0 because that's not a true statement. So I'm just going to worry about my two binomials of 2x minus 1 equals 0 and 2x plus 1 is equal to 0. And we're going to undo addition or subtraction first. So my first one, x is equal to half. And then my second one, x is equal to negative half. So here are my two zeros. Okay. One thing you can look for is your vertex. One way you can find your vertex is just to see what k is, because remember you're in your vertex form. We have h comma k, and technically this is almost in vertex form. So your vertex here would be 0, comma 16. There's no h, and the k is a 16. The next one we're going to look at a little bit more. This one is a trinomial, so you're going to go ahead and factor this one. Again, once you're done factoring, then we would be solving. So if I wanted to try this one, I'm going to set it equal to 0 first and factor out a negative 2 because that's my GCF. So I would have x squared plus 5x plus 6. And then I would do my factoring method. I notice that a is equal to 1, so I can do the AC method. 1 times 6 is 6. And the factors of 6 that add to 5 are 2 and 3. And because a is equal to 1, I can simply just write x plus 2 and x plus 3 is my answer for factoring. Still being factored out by negative 2, still equal to 0. And then again, I'm going to set both of these equal to 0 and solve. X plus 2 is equal to 0. X plus 3 is equal to 0. X is equal to negative 2, and x is equal to negative 3. So these are just finding the zeros for that. And maybe a good way too is you can write these in your ordered pair negative 2 comma 0, and negative 3 comma 0. That would be where you would actually plot those points because this is showing us again the x-intercepts. So here's one that you can go ahead and try. Again, let's pause it first, try it, and then click play. All you're doing is finding the zeros of the function. Immediately you should have seen for number 3 that you can factor out a GCF. So we're going to do that first. So x squared minus 4x plus 4. And then because a is equal to 1, I'm going to use the AC method. 1 times 4 is 4. And what factors of 4 would also give me negative 4? That is going to give me a negative 2 times negative 2. So those are both my binomials. So when I solve both of these, x minus 2 is equal to 0. Both of them, x is equal to 2. So I really only have one zero of the function. Sorry about that interruption. We have x is equal to 2 for both of my zeros, so really you only have to report 1. So my 0 would be 2 comma 0. That means this graph is only going to cross the x-axis once. Because I didn't have two zeros like before when I was seeing it, they were crossing it 2 times. This one is probably only going to cross it 1 time. The next thing we're going to talk about is what everything means in standard form. So you have the y-intercept would be equal to c. So remember, this is your standard form, ax squared plus bx plus c. The x-coordinate of the vertex is negative b over 2a, and the axis of symmetry is also equal to negative b over 2a. So what I'd like for you to write down is the standard form again, up here in the purple circle, and the stuff that's highlighted. This is just a picture on the right to show where everything would go. You don't need to sketch the picture, but again, if you'd like to, you can. But let's go ahead and pause so we can write down what's in the purple boxes and then click play to see how it's done. So what I'm going to do here first is I'm going to find the axis of symmetry and I'm going to find the vertex of the graph. Okay, so I'm starting with 2x squared plus 8x minus 1. And what I need to figure out first is the axis of symmetry. Remember before we wrote down that the axis of symmetry is negative b over 2a. So with that in mind, all I'm going to do here is just plug in my values. So I have negative, and then b is 8 over 2 times a, and a is 2. So that means I'm going to have negative 8 over 4, which is equal to negative 2. So part A, my axis of symmetry, is negative 2. So x is equal to negative 2. Letter B says to find the vertex. And again, what we're going to do for vertex, the y-intercept is c. That's not necessarily going to tell us our vertex. What we can do is plug in our x value and solve for the vertex. So I'm going to plug in x to find y. So, going back to my original problem, I have 2 times negative 2 squared plus 8 times negative 2 minus 1, and that's going to give me my y value, and then I'll be able to tell what the vertex is. Negative 2 squared is 4, and 8 times negative 2 is negative 16. 2 times 4 is 8, so 8 plus negative 16, and then minus 1 or plus negative 1 is going to give me negative 9. So since y is equal to negative 9, my part B for vertex would be negative 2 comma negative 9. So really the only thing you need to remember here is the negative b over 2a portion to help you find your x value for your axis of symmetry. Once you find that, then you can plug in x back to your original equation or function to solve for y and also to get your vertex. So let's go ahead and try this one here. Let's find the axis of symmetry and a vertex, and then once you're done, click play to check your work. Alright, so what I did first to find my axis of symmetry is plugged in negative b over 2a. So I have negative 6 over 2 times 1, which is negative 6 over 2. That's going to give me an x value of negative 3. So my part A, axis of symmetry, x is equal to negative 3. For vertex, I'm going to plug in that negative 3 back into my problem to get my y value. So negative 3 squared plus 6 times negative 3 plus 5 is going to give me that y value. So I'll have 9 minus 18 plus 5, and that is going to give me a negative 4. So my vertex would be negative 3, comma, negative 4. Okay. The last part we're going to talk about is determining whether a graph has a minimum value or a maximum value. Again, there's a lot on here, and I only need you to write down the essential things. The maximum value in standard form is when a is less than 0. The minimum value, it has a minimum value when a is greater than 0. So it's kind of like opposites. Your max is when a is less than 0. Your min is when a is greater than 0, because anytime you graph something where a is less than 0, it's going to be facing downward, so it's always going to have a maximum. Anytime you have a graph where a is greater than 0, it's going to be facing upwards, so then you would have a minimum. Okay, so what we're going to do is pause for number 6, write down what you need to have a minimum and a maximum value, and then click play to see how it's done. So this question says, tell whether the function f of x is equal to negative 4x squared minus 24x minus 19 has a minimum value or maximum value, and then found the value or the y coordinate. So we're still going to do that negative b over 2a to find the y coordinate. So for this one, we notice that we have a being equal to negative 4. Since a is equal to negative 4, that means a is less than 0, which means it would have a maximum value. So let's go ahead and try to find that maximum value. The first thing we need to do is find our x. So we're going to do negative b over 2a. This negative just means that the whole entire thing would be negative once you're done, unless you have two double negatives, and that's going to change it to a positive. So I'm going to go ahead and plug in my negative 24 over 2 times negative 4. So negative 24, that's going to give me negative 24 over negative 8. Still a negative on the outside. That would be a positive 3, but then we have to keep the negative, so technically it'll be a negative 3. So because x is equal to negative 3, I'm going to go back and plug it in. So negative 4, parentheses, negative 3 squared minus 24 times negative 3 minus 19. All through those calculations are going to give me 17. So the max value, or the y-intercept, is 17. Okay, so that's all you have to do. Determine whether it's a max or a min, and then try to find your y-intercept by using the negative b over 2a. This one you're going to try. This is your last one in your notes. So again, let's pause this one. Go ahead and try number 7, and then once you're done, click play to check your work. Alright, we see that a in this one is equal to 8, and that means a is greater than 0. So that means we have a min value, or a minimum value. Now we're ready to go ahead and find that value. So what we're going to do is find my x coordinate first, using negative b over 2a, and then plug that in to find y. So I have negative b, which would be negative 8 over 2 times 8. So that's going to be negative 8 over 16, which is negative 1/2. But because I have this negative on the outside, that's going to change it to a positive 1/2. So my x value is equal to a positive 1/2. So let's go back and plug it in. So here's me where I plugged in my value of x. I'm going to go ahead and start using my order of operations. So 8 times 1/4 minus 8 times 1/2 plus 6. 8 times 1/4, that's going to give me 2, minus 4 plus 6. When I solve that, I'm going to get 4. So my minimum value is y is equal to 4. Okay? That's going to conclude our notes for today. Thanks so much for tuning in, and we'll catch you next time.